Why do most car batteries fail sooner than expected? And could your habits be the reason why? It's not always a faulty battery. Often it's what drivers do every day, without even thinking about it. With a few key changes, you can extend your battery's life significantly. So, are you overloading your battery without knowing it? Are you missing early signs of failure? And do your daily routines unknowingly shorten its lifespan? In today's video, we'll look at all the things you should do to make your battery last longer. And make sure to stick around until the end because I've got a bonus tip that could save you thousands in repairs. Let's begin with one of the most overlooked factors in battery care, the fluid inside the battery itself. Many car owners don't realize that traditional lead-acid batteries rely on a precise mixture of water and sulfuric acid, known as the electrolyte solution. Over time, especially in warmer climates, the water in this solution slowly evaporates. If the fluid level drops too low, the metal plates inside the battery become exposed to air. That's when the real damage begins: corrosion, overheating, and rapid loss of performance. Checking battery fluid isn't complicated and it doesn't require professional tools. If your battery has removable caps, usually two rectangular ones at the top, you can inspect the fluid level inside each cell. The liquid should always cover the internal lead plates. If it's low, top it off with distilled water only. Tap water contains minerals that can interfere with the chemical balance of the battery and accelerate deterioration. For vehicles with sealed or maintenance-free batteries, you won't be able to top off fluid manually, but that doesn't mean you can ignore them. Regularly check for signs of swelling, warping, or leaking around the casing. These are early indicators that your battery may be overheating or internally damaged. Monitoring fluid levels may seem minor, but it plays a critical role in battery life. A battery low on fluid is not just underperforming, it's silently dying from the inside out. Making this quick inspection part of your regular maintenance routine could prevent a total failure and add years to your battery's service. While what's happening inside the battery matters, what we do before turning off the car can have just as much impact. Turning off electrical devices before shutting off the engine is one of the easiest ways to reduce unnecessary strain on your battery. Yet it's a habit most people overlook. Think about this. Every time you leave the headlights on, the air conditioning running, or the phone charger plugged in after switching off the ignition, your battery is left to handle all those loads without help from the alternator. When the engine is running, the alternator supplies power to the car's electrical systems and simultaneously charges the battery. But once you turn the engine off, anything left switched on draws directly from the battery alone. That includes things like your radio, climate controls, power seats, or even dashboard cameras. If this becomes a routine, your battery is constantly being drained after shutdown, forcing it to work harder the next time you start the engine. This is especially problematic in colder temperatures or for vehicles with older batteries. A weakened battery combined with parasitic drain is a recipe for failure, usually at the most inconvenient moment. The fix is simple but effective. Develop a habit of turning off all unnecessary electrical devices before shutting off the engine. Make it second nature. Headlights off, AC off, USB ports cleared. This reduces the load on the battery and gives it a better chance to recover and hold a full charge for longer. Making this a routine practice not only protects the battery but also improves your car's long-term electrical health. And once you've taken care of both the battery's internal fluid condition and its external electrical load, it's time to move on to another critical maintenance task that often gets ignored: keeping the battery terminals clean and secure. Another simple but often neglected habit that affects battery performance is keeping the terminals clean and properly tightened. Over time, corrosion builds up on the battery terminals, those metal connectors where the cables meet the battery. This corrosion isn't just unsightly. It creates electrical resistance, meaning the power generated by the battery struggles to travel through the vehicle's systems. Corroded terminals make the battery work harder during engine startup. That extra strain causes heat, which accelerates wear on internal components. Left unchecked, this can shorten the battery's lifespan significantly. In some cases, a heavily corroded terminal can prevent the car from starting altogether. Cleaning terminals is a 5-minute job that requires nothing more than a wire brush and some terminal cleaner, or even a simple mixture of baking soda and water. Scrub the terminals until the metal is shiny and free of buildup. Once clean, it's equally important to ensure the clamps are securely tightened. A loose connection can be just as harmful as a corroded one, leading to unstable voltage delivery, flickering lights, or erratic sensor behavior. Applying a terminal protector spray or a dab of petroleum jelly can also help prevent future corrosion. With terminals clean and connections tight, your battery can deliver consistent power and operate without interruption, especially during cold starts or when handling high-demand electronics. Now that the flow of electricity is no longer restricted, the next question is whether the battery itself is powerful enough for your vehicle's needs. Not all car batteries are created equal, and choosing the wrong one can set your electrical system up for failure. Every car has specific requirements based on engine size, climate, and electrical demand. These specifications usually include the group size, reserve capacity, and something called cold cranking amps, which refers to how much power the battery can deliver at 0 degrees Fahrenheit. If the battery in your vehicle has lower cold cranking amps than recommended, it might struggle to start in cold weather, especially if you use multiple electronics like heated seats, infotainment systems, and charging ports. Manufacturers sometimes equip vehicles with just enough battery capacity to meet baseline requirements, often prioritizing cost savings or weight reduction. Upgrading to a higher performance battery, one with slightly more cold cranking amps or reserve capacity, can make a noticeable difference. For example, if your car came with a battery rated at 500 cold cranking amps, switching to one rated at 700 could improve cold start reliability and extend the battery's life under stress. It's not about overspending. It's about matching the battery to your driving conditions. Always consult your owner's manual or a trusted parts specialist to verify the correct specifications. Then, choose a battery that meets or slightly exceeds those numbers. The added durability and performance are worth the modest difference in cost, but even the best battery can fail early if the system designed to keep it charged isn't functioning properly. The alternator plays a critical role in maintaining battery health. Once the car is running, the alternator takes over from the battery, supplying power to the vehicle's electrical systems and recharging the battery at the same time. If the alternator is failing or underperforming, it can cause two major problems: undercharging or overcharging the battery. An undercharged battery never receives enough energy to fully recover from each engine start. It runs in a constant state of depletion, which encourages internal sulfation, a chemical buildup that weakens the battery over time. On the other hand, an overcharging alternator can send too much voltage to the battery, overheating it and potentially causing the casing to swell, leak, or fail altogether. Common signs of alternator issues include dimming or flickering headlights, dashboard warning lights, or an unusual whining noise under the hood. In more advanced cases, you may notice irregular behavior from electronic components like window motors or infotainment screens. Routine alternator checks during oil changes or service visits can prevent serious problems. Many auto shops will test both your alternator and battery for free. Alternatively, a home battery and charging system tester, available for about $50, can provide real-time voltage readings. This small investment gives you clear visibility into the health of your vehicle's charging system and helps avoid being blindsided by battery issues. When the alternator is functioning as it should, it complements a good battery, creating a balanced, efficient electrical system. But even then, how you use your vehicle day to day still plays a big role in how long that battery lasts. One of the most common but invisible ways drivers shorten their battery's life is by taking frequent short trips. Every time you start your car, the battery provides a high burst of energy to crank the engine. This initial demand is significant, especially in colder weather or with older batteries. After that, the alternator takes over and begins recharging the battery. But that process takes time. If your trip only lasts 5 or 10 minutes, the alternator rarely has enough time to fully recharge what was used. This leads to a repetitive cycle of partial discharges. Over time, these incomplete recharge cycles prevent the battery from reaching a full state of charge, and that reduced capacity gradually becomes permanent. The result is a battery that seems fine until it suddenly fails when pushed, like during a cold morning or after leaving the lights on briefly. A better habit is to combine short errands into one longer trip whenever possible. Aim for at least 20 to 30 minutes of driving time, ideally on roads without constant stopping. This gives the alternator the opportunity to restore the battery fully, keeping it healthy and reducing the chance of sulfation. If your routine simply doesn't allow for longer drives, perhaps you work remotely or only use your car occasionally, then consider installing a smart battery maintainer. These devices plug into a wall socket and connect to your battery, delivering a safe, consistent charge that mimics normal driving usage. Beyond driving habits, the environment where your car sits plays a surprisingly important role in battery longevity. Heat is one of the most damaging elements for a car battery. While cold weather makes it harder to start an engine, heat is what silently breaks a battery down from the inside. High temperatures accelerate the evaporation of the battery's internal fluids, which leads to corrosion on the internal plates and eventually causes the battery to lose capacity. Even in sealed batteries, excessive heat can lead to swelling and decreased efficiency. This is especially true if the vehicle is regularly parked in direct sunlight or on hot pavement. Under-hood temperatures can exceed 150 degrees Fahrenheit during the summer, and that thermal stress shortens battery life significantly. The solution is straightforward. Park in a shaded area whenever possible. A garage, carport, or even under a tree can drastically reduce heat exposure. If no shade is available, using a reflective windshield cover helps keep interior temperatures down and indirectly reduces the heat radiating back onto the battery from the engine compartment. In extreme climates, some drivers go a step further and insulate the battery with a heat shield or thermal wrap, especially for vehicles that sit idle during the day. These products are inexpensive and can extend battery life by protecting it from both heat and vibration. Even with proper parking and insulation, prolonged periods of inactivity can still degrade your battery in silence. Car batteries are not designed to sit idle for weeks or months at a time. Even when the vehicle is turned off, there are still small electrical systems drawing power, security systems, clock settings, or diagnostic memory. This is known as parasitic drain, and over time it causes the battery's voltage to drop below a critical threshold. Once a lead-acid battery drops below 12 volts and stays there for an extended period, it begins to sulfate, a chemical process where lead sulfate crystals build up on the battery plates. These crystals make it more difficult for the battery to hold a charge and reduce its ability to deliver power efficiently. In many cases, the damage is irreversible. If you know your car won't be used for more than 2 weeks, make it a habit to start the engine once a week and let it run for at least 20 minutes. This allows the alternator to top off the battery and keeps engine fluid circulating, which also benefits the engine itself. For longer periods, such as during extended travel or seasonal storage, use a battery tender or trickle charger. These devices maintain a steady, safe voltage level and prevent deep discharge without overcharging. They're especially useful for secondary vehicles, motorcycles, or classic cars that are not driven regularly. Avoiding long idle periods isn't just about preserving charge, it's about preserving the chemical structure inside your battery. Keeping it active is one of the best defenses against early failure. And once that battery is properly charged and protected, the final step is to ensure that it stays physically secure under the hood. A factor that often goes unnoticed, yet has serious consequences, is whether the battery is properly secured in its mounting tray. A loosely mounted battery may shift or vibrate excessively while the vehicle is in motion, especially on rough roads or during sharp turns. This movement over time leads to physical stress on the battery casing and its internal components. When a battery vibrates constantly, it can cause the internal lead plates to crack or separate. These internal failures are not visible from the outside but will gradually reduce the battery's ability to store and deliver charge. In some cases, a loose battery may even tip slightly, leading to acid leaks or, worse, a dangerous short circuit if the terminals come into contact with surrounding metal. Securing the battery is straightforward. Every battery should be firmly clamped into its designated tray using the factory-approved hold-down bracket or strap. The goal is to keep it snug enough to prevent movement, but not so tight that it risks cracking the battery casing. Over-tightening is a common mistake and can cause just as much harm. It's also good practice to check the battery's position periodically, especially after driving on unpaved or bumpy roads. If you ever hear a subtle thump or see movement when touching the battery by hand, that's a sign the mounting should be rechecked. By securing the battery physically, you're helping protect it from mechanical damage that shortens its lifespan. But while mechanical stability is critical, perhaps the most important aspect of battery care is something many drivers ignore until it's too late: the warning signs of battery failure. Understanding the early symptoms of a weakening battery can save you from being stranded or facing a costly emergency repair. One of the most common signs is slow engine cranking. If you notice the engine takes longer than usual to turn over when you start the car, especially first thing in the morning, your battery may be losing its charge capacity. Similarly, dim headlights, particularly when idling or just after startup, often point to a battery struggling to supply adequate voltage. Another common symptom is erratic electrical behavior, such as flickering dashboard lights, malfunctioning power windows, or infotainment systems resetting unexpectedly. In modern vehicles, where electronics are deeply integrated into all systems, even minor voltage fluctuations can cause noticeable problems. These signs don't always mean immediate battery failure, but they do signal that the battery should be tested without delay. Many auto parts retailers offer free battery testing, and portable digital testers are available for home use at a reasonable cost. These devices provide quick readings of the battery's state of charge, voltage under load, and overall health. Testing early allows you to plan a replacement on your terms, rather than being caught off guard during bad weather late at night or in the middle of a journey. More importantly, it helps you avoid damage to other electrical components that depend on a stable power supply. By paying attention to these warning signs and acting before the battery reaches critical failure, you not only protect your vehicle, you protect your time, your safety, and your wallet. These 10 habits may seem small on their own, but together, they form a powerful defense against premature battery failure. And in the long run, they could make the difference between a battery that dies in 2 years and one that keeps going strong for 5 or more. With that, we have reached the end of today's video. If you have come this far with us, be sure to check out other videos on the channel.